talk about solving systems of nonlinear functions. So what that means is that you have one, two, or more functions of a system that are not linear. Let's do a couple examples of what that might look like. For example, if one of the functions was nonlinear, let's say maybe a parabola, and the other one was linear, how many times do these two functions cross? You can see there are two solutions to the situation. How about another one? Let's say we had, in this one, let's do two nonlinear functions. So maybe a parabola that opens down and a parabola that opens up. Again, in this situation, there are two solutions. How about if we had, how about a cubic function? And with the cubic function, maybe we had a parabola. How many solutions do we have this time? You can see they cross 1, 2, and 3 times. So many different things can happen when you're talking about nonlinear functions. The only way to solve nonlinear functions is algebraically. So we're going to talk about solving these using our algebra skills. And in all of these, we're going to do it by substitution. Alright, so first thing you want to do is isolate a term in one of the equations that is identical to a term in the other equation. Maybe that's x, maybe that's x squared, maybe that's 3x squared. Two, you want to substitute the terms equivalent, and I usually have you put a box around what that equals, right? So that terms equivalent into the other equation. Three, you want to solve for the remaining variable. Step 4, plug all. So if there's 2 x's you get, if there's 3 y's you get, you want to plug all the solutions back in to find the point. And again, remember that these are places where they intersect, so they're points, and they have to be written as such. So let's try an example. Here's example number 1 today. All right, let's say we have y equals 4x squared, and we have 4x plus y equals 1. All right, so we know the first one's a parabola, and the bottom one is a line. So these can cross 1, 2, or no, fine. So we have to do our algebra in order to figure this out. Now we do have a variable all by itself. So what we've always done in class is I asked you to put a box around that, and you're going to sub that into the other equation for y. So I have 4x plus, where y is, I have 4x squared equals 1. Now, of course, we want to set this whole thing equal to 0. So I'm going to actually put this in the right order at the same time. So I'm going to put my 4x squared first, plus 4x minus 1 equals 0. This is a negative here. Negative here. We're going to make that a positive. I apologize for that mistake. All right, so now we have a couple choices. We can factor to find our x values. You could do the quadratic formula to find your x values. So you have some different options. I'm going to factor today. So first I'm going to draw my x. Last number times the first is 4. Middle number is 4. Sides of my x would be 2 and 2. And of course, since the leading coefficient is not 1, we're going to throw it in the box. We have 4x squared in the first spot. We have 1 in the last spot. And of course, the sides of our x are our diagonal. Undistributing out of the first one, we get 2x. Undistributing out of the bottom one, we get a positive 1. Up and down, undistributing, we get 2x. And of course, positive 1. So you'll notice this factor is 2x plus 1. And technically it's squared. We're going to set those factors equal to 0. If we set that equal to 0 and solve, we end up with x equaling, subtracting 1 to the other side and dividing by 2, a negative 1/2. Now again, I want to remind you that this is a multiplicity of 2. And what does a multiplicity of 2 mean? That really means that it touches the other, right? So when we had a multiplicity of 2, we said it touched and bounced off the x-axis. Here, when we're trying to compare the two, they're going to just touch. So we're just touching in one spot. I'm going to take this negative 1/2 now, and we're going to plug it back in. So we have y equals 4, our negative 1/2 squared. Solving for y, we get y equals 4 times negative 1/2 times negative 1/2 is 1/4. And we get y equals 1. Now we know we're not done. Remember that you need to write the solution as a point. This point would be negative 1/2 and 1. Now if you were to graph this, throwing that into your graphing calculator, of course, you first have this parabola that kind of looks like that. And then we would probably have a line that at negative 1/2, 1 contacted the graph right about there. It looks something like that in our graphing calculator. All right, so let's try another one. Example number 2 today. Example 2. Let's just make this a little bit tougher. Let's say I have y equals x to the third plus x squared. So now we have a cubic function. And we have y equals 4x squared. All right, and we have a parabola. Now you do notice that they both are equal to y. And what do we always say in class? When they both equal y, we can set them equal to each other. We have x to the third plus x squared, and we're going to set that equal to 4x squared. Now, of course, we want to set equal to 0. So I'm going to move my 4x squared to the other side. I get x to the third minus 3x squared equals 0. Now we want to factor. I can undistribute an x squared out of both of these. Leaves me with x minus 3 equals 0. And now we said both of these factors equal to 0. So I get x equals 0, of course, with a multiplicity of 2, which means at this point it's going to touch the other one. And here, if I take the x minus 3, set that equal to 0, I get x equals a positive 3. So we do have two different x's, which means we have two different points where these graphs intersect. We're going to start with the 0. Let's plug that in. We have y equals 4 times 0 squared, which means y equals 0. So the point where this is going to touch is at the point 0, 0. They touch. This is actually called a tangent to the other one because they touch one another. All right, let's plug 3 in. So we have y equals 4 times 3 squared. Now you could have plugged it in the top one. It doesn't matter, whichever one works for you. We have y equals 4 times 9, which which means y equals 36. So the second point we have here is at the point 3 and 36. And again, we want to make sure we write them as a point. Shall we try another one? Example 3. All right. Let's start off with x squared plus y squared equals 9. This is a circle, right, with a radius of 3. And we have x plus 3y equals 4. And we have a line. So, either we have a circle with a line that crosses through it twice, or we have a circle where the line just touches it. Let's see what happens. So, first we need to get one of these by itself so that we can plug it into the other equation. Because the x has a coefficient of 1, this is going to be our easiest approach. Subtracting 3y to the other side, we get x equals negative 3y plus 4. We'll be able to take this, negative 3y plus 4, and plug it in for x in our other equation. So we have negative 3y plus 4 squared plus y squared equals 9. And of course, if you have a binomial that's squared, in order to multiply that, you have to FOIL or throw it in the box. So you have negative 3y plus 4 times negative 3y plus 4. Negative 3y times negative 3y is 9y squared. Negative 3y times 4 is negative 12y. Here is negative 12y. And of course, 4 times 4 is 16. So, squaring this out, we get 9y squared. Adding our diagonals together, negative 24y plus 16 plus y squared equals 9. All right, so let's combine like terms. So I have, let's see, I have 10y squared minus 24y plus 16 equals 9. All right, let's move our 9 to the other side. So we're setting it equal to 0. So we have 10y squared minus 24y. Subtracting 9, we get plus 7 equals 0. Okay, so we have this quadratic here. Willing factor, I don't know, the numbers are kind of big, so let's do the quadratic formula. Again, remembering this is A, this is B, and this is C. So let's move our quadratic formula right over. Actually, let's move it down underneath. We'll go down a little. All right, so we have negative B, so 24, plus and minus the square root of B squared, so 24 times 24, which is 576, minus 4 times A times C, all over 2 times A, or 20. All right, so simplifying this top, 576 minus 280, we get 296. And I believe 4 comes out of that. So we're left with 24 plus and minus 2 roots. 74 all over 20. Now you can see this does reduce. So 2 goes into 24 12 times, 2 goes into 2 once, and 2 goes into 20 10. So we have y equals 12 plus and minus root 74 over 10. All right. We have 2 solutions for y, which means when we're done, we have to have 2 solutions for x. We're going to take this y and we're going to plug it back in to our equation. Okay? So let's start with taking our y and we're going to put it in here. We have x equals negative 3 times our y. So 12 plus and minus 7 square root 74 over 10 plus 4. All right, lots of different ways to simplify this. I have x equals, we can go ahead and multiply or distribute the negative 3 through. So we have, let's see, negative 36 plus and minus a negative 3, so that just leaves the signs the same. Square root 74 over 10 plus 4. Now, I personally, to make it a little bit easier to simplify, for me, I would probably clear the fraction. So I would multiply 10 times x. And here when I multiply this one by 10, my 10's cancel. So I have negative 36 plus and minus 3 square root 74 plus 40. So by doing that, it makes it easier for me to combine these like terms here, this negative 36 and the positive 40. So I have 10x equals, now negative 36 and 40 is 4, plus and minus 3 square root 74, and then of course I can divide both sides by 10. So I find out that x equals 4 plus and minus 3 square root 74 all over 10. So now, how do these 2 points go together? Well, remember right here when I distribute the negative 3 through, this technically flipped these signs. So really, this is a negative over a positive, right? Same thing here, we have negative over positive, negative over positive. So really, it's the negative form of this that goes with the positive form of y. So our first point we would have would be 4 minus 3 square root 74 over 10, and the y value would be 12 plus the square root of 74 over 10. The second point would be 4 plus 3 square root 74 over 10, and then the second one would be 12 minus the square root of 74 over 10. Now, this is the exact answer, of course. I think it'd be good if we try one more of these. Let's do another one. So here we go with example number 4. I'm going to follow that same idea. I think it's good practice for us to use our quadratic formula and then plug in that quadratic formula and see how that works. Okay? So let's try it a little bit different this time. But if I have x squared plus y squared equals 4, and let's say I have x plus 2y equals 3. Again, we have a circle with a radius of 2 and a line that's going to cross through it. Alright, so the first thing we need to do is get this x by itself, just like we did on the previous example. So I'm going to move that 2y to the other side. I get x equals negative 2y plus 3. I'm going to take this negative 2y plus 3 and plug it into our other equation for x. So we have negative 2y plus 3 squared plus y squared equals 4. Of course, we need to FOIL this out or put it in the box to multiply that. Negative 2y plus 3 times negative 2y plus 3. Negative 2y times negative 2y is 4y squared. Negative 2y times 3 is negative 6y. Negative 2y times 3, negative 6y. And 3 times 3 is 9. So in this first part, when we multiply or square that out, we get 4y squared. Adding our diagonals together, minus 12y plus 9. And then plus 4y, plus y squared equals 4. Alright, and this was when we squared it out, and then of course we still have the plus y equals 4. Combining like terms, we're going to have 5y squared minus 12y. Now I'm going to subtract my 4 over at the same time as combining like terms and setting this equals to 0. So I have plus 5 equals 0. So if I were to think about factoring it, I would take 5 times 5, which is 25. That would go on top. And negative 12 on the bottom. Are there two factors of 25 that are going to give me negative 12? Of course not. So this does not factor. So, of course, we have to use the quadratic formula. Again, I want to remind you, this is our A, this is our B, and this is our C. Let's plug it in. We have negative b, or 12, plus and minus the square root, b squared, 144, minus 4 times a times c, all over 2a. All right, let's simplify this. 144 minus 100 is 44. And of course, 4 can come out of that. So I have 12 plus and minus 2 root 11 over 10. And of course, we have the 12, 2, and 10 will all reduce. Let's grab our red here. 2 goes into 12 6 times, 2 goes into 2 once, and 2 goes into 10 5 times. Move that out just a little bit, not quite that far. There we go. All right, so we came up with y equals 6 plus and minus square root 11 divided by 5. Again, we have two solutions for y. So in this case, we have to plug this in to our equation. All right, now you can do them separately, or again, like we did on the last problem, you can do them together. I think this time, let's do them separately so you can see how those signs change. All right, so I'm going to plug the 6 plus the square root 11 over 5 in for y. So x equals negative 2 times 6 plus square root 11 over 5 plus 3. I'm going to distribute the negative 2. So I have x equals negative 2 times 6 is negative 12. Negative 2 times a positive square root 11 is negative square root 11. This is still all over 5, and then plus 3. Again, I like to clear the fraction because it makes it easier to see when you're combining like terms. So I'm going to multiply everything by 5. That would give me a 5x equals, and technically this is in parentheses, so when I multiply it by 5, these would cancel. So I have negative 12 minus square root 11, and don't forget to multiply the 3 by 5, right? So plus 15. Now, a lot of times in class we will put the little 5 next to it to help us remember what we're doing to each term. And you can see here these would cancel. All right, so now we can collect like terms. I have 5x equals negative 12 and 15 is positive 3. I have minus square root 11. So then how do I get x by itself? I'm going to divide both sides by 5. So in this case, my first point I have, my x value is 3 minus square root 11 over 5, when my y value was 6 plus square root 11 over 5. All right? Now we can go through and do the same thing. What do you think is going to happen between these signs? Same thing it did on our last example. We're going to have 3 plus square root 11 over 5, and 6 minus the square root 11 over 5. All right, so that's how we do it algebraically. What's another way that we can find these intersection points? Let's talk about using our graphing calculator. All right, so I do want to remind you guys that there's several different apps available to get a graphing calculator if you need it. There's lots of different sites. What we use at school is that TI-84 Plus, and we do use the silver edition, but again, that's what we use at school. That's what we're used to using, so if you can find that. Remember, we've done Web@Emu on your phone for those of you that have an Android. But again, there's lots of different places online that you can find this calculator. So I want to go through those steps to find the intersection points using our calculator. So step 1, you're going to want to get the y's in all of your equations isolated. Step 2, you're going to plug each of those y functions in to y1, y2, possibly y3, depending. Step 3, you're going to want to hit graph. Step 4, Now we hit second and calculate. You want to go move down to intersect and hit enter. All right, 5. Here, when you hit enter, you're going to have this flashing cursor on the first curve. And you'll see underneath the graph it says first curve. You want to make sure that your cursor is close to the first point you want to do. So either move right or left to be close to the intersection. All right, so once you do that, you want to hit enter. Your calculator will automatically go to the second curve. Again, it's got a flashing cursor. On second curve. Again, you want to move that cursor, right, close to the intersection point. That way you're doing the correct or the same point that you want. Okay? I prefer to start with the leftmost point and then do the right point, but it's up to you. And again, you're going to hit enter. Now, remember when your calculator is thinking, it comes up with guess with a question mark. That just means your calculator is thinking, it's giving you what you want, so you're going to hit enter. 8. You're going to state the point that's shown. So usually they tell you what X and Y are. It's underneath or at the bottom of the graph. And of course you want to write it as a point. Step 9, repeat this process, so steps 4 through 8, for any other point. Any other point. All right. So now I really wish that I had some way to put a calculator up here and go through those steps with you, but there is a couple things I do want to point out. So let's talk about on your worksheet, for example, I want to just briefly talk about number 7 on the worksheet. On number 7, the first equation is x squared plus y squared equals 13.85. Well, what is this? That's a circle, right? Well, we need to get the y by itself. So we're going to subtract x squared to the other side. So y squared equals negative x squared plus 1385. Or you can put the 13.85 first minus x squared. Doesn't matter. Now, how do you get rid of the square? You're going to square root both sides. When you square root both sides, y equals positive and a negative square root of negative x squared plus 1385. Alright, so you put y equals the positive 1 in one line and y equals the negative 1 in the other line. What that does is the positive is the top half of your circle, the negative is the bottom half of your circle. Alright, if you have any questions, please let me know. Again, the other option is if you can't find a graphing calculator, you can always contact Mr. Sturm. I'm sure we can work something out. All right, you guys, have a great day.